Okay. Come on. Of course, I have to turn on everything. And now we're talking. Okay. So this is the title of today's session. How many of you have any interaction with Azure whatsoever? Okay. Oh, great. Then you're seniors. Fantastic. So a few words about me. Nikos Delis is my name. I'm a cloud engineer, a freelancer. I work for myself today. I work a lot with Azure, and I have a few certifications that prove that and make it easier for me to get consultancy assignments. I have a blog called ndtechnique.com. I do a podcast called Azure Triumphs, where I interview people with exceptional experience about Azure. I am a co-organizer of an Azure community called Azure Skåne in the southern region of Sweden. And you can reach me on my social media down there, X, LinkedIn, and I have a GitHub account also. So the story I'm about to tell you today started in the beginning of a new assignment where I was freshly employed by that consultancy. So I was a consultant. How many consultants do I have in the room? None? Okay. Does the consultancy thing work in this area? Actually, consultancy means that we have a company who has employed a number of engineers, but they don't use them themselves. They rent them by hour to other clients. So that was my role. And to that specific assignment, before I got the architect role for that project, we had another architect and two other developers. And my new employer asked me to make the best I can to make the developers 4 from 2, which of course means more money, and to extend the architect assignment for at least 1 year. Now we have a saying in Greece, here comes some Greek, "Η καλή μέρα από το πρωί φαίνεται." This means from the beginning of the day, you're going to know if it's going to be a good day. So my first day at this client went like this. I went to meet the CTO, we shake hands. Hello, my name is Nikos, I'm the new architect. Yeah, hello, we're finishing with you. You're done. We're closing the assignment. That's what they told me. So I went there to increase the portion of the project we had, and the first thing I heard is that they're going to finish the project for us. All of us are done. To which my reaction, of course, was a poker face. But okay, yeah, what can we do? We can finish with the flag up. We can finish in the best possible way. And to do this, I use the things that I always use. First of all, my best tip, whatever you do, under promise, over deliver. Do you know Azure Functions? I'm not sure, kind of heard of those. In fact, I've built thousands of Azure Functions. Then always be humble. I mean, you don't know what the previous architect did and why it ended up the way it ended up. And by being humble and by telling them, I will do my best, I can try some things I know and I can learn from you. Then you build a relationship of trust, which is going to give you value for the rest of the project. Then, of course, you want to try things, but being at a client means that you're not in school anymore. They don't pay you to learn from them, they pay you to create solutions for them. So it's okay to fail, but please fail fast. Would you like to take a seat? There's plenty of, okay. So, now about the project. This is the WowCow data flow. And this is actually not a real deal because it's actually a whole different industry, but it's the same model. So the real client didn't do dairy products like milk, butter, yogurt. They did a whole different thing of products, but I don't want to reveal which client it is. You will understand why. But I still want to make you understand what it is about. So we have a client, let's call them WowCow, and they are a dairy producer. So they produce dairy products. And how do they sell those products? They sell them via the supermarkets everywhere in the country. Sweden is a big country, a very long country also, and this will play its role in the rest of the project. So they send their products with trucks to the supermarkets, and then the supermarkets will try to sell them. And in the end of the day, they will report back to the dairy producer, this is how much we managed to sell, and this is how much is going to to be bad, so we send it back to you to do whatever you want with it. So they are sending back new orders. This, of course, goes via Azure. It goes back to the dairy producer, and then the invoices are automatically created and sent to the supermarket. So it's not rocket science. It's a pretty simple chain of events. But this is about how it goes. So, okay, now I know. Now I understand what you do. What seems to be the problem? And what isn't the problem? Everything is problematic. We have orders disappearing. The logs say nothing. The user experience is horrible. We are late invoicing, and this is the worst thing because organizations like supermarkets, they are very picky with their invoicing. They need it to be on time, and they need it to be in the correct manner and with the correct products and everything. And the biggest problem of all was that nothing works during rush hours. Now, I remind you, Sweden is a big country, a long country, and rush hours mean different things for different clients. We have a lot of supermarkets in Stockholm, Gothenburg, and Malmö, but we don't have that many in smaller cities. The thing is that since we don't have that many in smaller cities, the ones that we do have are very, very big, and they order quite a lot. Also, the bigger the supermarket, the longer opening hours it has. So they open 7 o'clock in the morning, and they close 11 p.m. in the evening. All of them, simultaneously. Keep that in mind. Okay, I understand. Let's take a look at the architecture. Let's take a look under the hood. And I see that. And I know what you think. This is a dumpster fire. But in real, where do we have problem? Well, we have here and there 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 and there. So these are the problems we have. And this is the biggest one. This is why I got there, actually, because money are disappearing. So we have a few logic apps talking to each other and talking to Azure functions, and then they grab data from an SQL server, and then they're sending it to an Azure data factory, which in its turn sends it to another database on premises. This is their on-premises data center. This is Azure, and here is the portal that the supermarkets are using to send their orders. Of course, nobody is calling anyone. They have a web page. And this is where the frustration is, because when they want to put an order, as I said, when do? They put it in the end of the day. And what happens after they put the order? They go home. And they want to go home. They want it really bad. So they don't want to wait. And since all this thing is happening, and it crashes and takes a lot of time, they have to wait a lot. And they just want to go home. Okay, so let's take it easy. One thing at a time, let's find some issues. So, the logic app connectors have limitations. This is the first issue I recognize. Here are the logic apps again, those. So when they talk to each other, especially this one was the worst, because a logic app can send data to the Azure data factory, which is an Azure resource that is channelizing data to other resources, but it only can send 100 endpoint requests per minute. So it is fast. It does send those 100 requests in a few seconds, but then for the rest, 50, 45, 30 seconds, it just waits. Put them in the queue. So although it has what it needs, it can't perform. Then also, talking to the SQL server way too often means that the SQL server, the network parts of the SQL server are going to feel bad. So the connector had limitations. We have the cheapest tiers on everything because the previous architect told the client that Azure is free. Free? I mean, that's okay. You took it a bit too long. You can tell them that it's going to be cheaper. You can tell them it's going to be better than what you pay today. But free? I mean, come on, that was a bit over the limit. Then the fact that API management here, and I remind you, API management is this one. It's the entry to the whole machinery. Needs to wait for the whole thing to get done before letting the API know that now we're done. Now you can get your 200 and go home. This creates a long wait time. lots of unnecessary database interaction. And of course, since we're in free tiers, we have pretty much zero scaling options. We're on serverless everything, so we hope we don't get noisy neighbors, but we do get a lot of those. And then the low-code stuff, I mean, come on. After COVID, I realized that people started selling a lot of logic apps, Power Automate, all that stuff, telling the clients that you can do whatever you want by yourself. After calling me and talking to me for an hour, then if you're going to do that, why not write code? C#, like usual code, the one we all love. So the solution is just, come on, kill the logic apps, right? Oh, and one more thing. While I was taking my time to understand what's going on, and the backend team trying to troubleshoot and identify the errors and grave in the logs and all that stuff, the front-end team found a solution. What solution was that? Well, before I tell you the solution, they're not so idiot as they sound when they proposed this, that instead of doing one order with n number of items, so one order with 100 bottles of milk, one order with 20 packets of butter, let's do one order per item. To which my reaction was this again, because this means that instead of having 2,000 orders per day, I would have 80,000 orders per day. So I'm like fighting to keep my performance down, to keep everything cheap and to keep everything functional. And you just, I don't even know how to say, quadrupled. For 40 times, you made my flow 40 times more than what it was before, which is a very bad thing. Now, why did they do it? They did it because, as I did, they looked in the logs and they found out that the smaller supermarkets never have performance issues. Why? Why could that be? Because they don't close 11 o'clock. Because they're run by you and me and you and you and you, like anybody. And when I feel it's time to go home, I just go home. I don't have standard opening and closing hours, and I can do the orders from my home. They don't have to be there. So they did find an explanation, but the explanation wasn't connected to reality. They didn't have better performance because they were small. They had better performance because they also had experienced the performance issues, and they tried and error and found out that if I do my orders an hour later, then it works fine. So that's what they did. Okay. So, but this is done. It took like 60 sprints to build. They had the UX team that is super duper UX, very nice people doing everything. But what does it mean for us? Well, let's start fixing this thing. First of all, let's take the lowest effort, the low-hanging fruits, and the simplest things that will make the bigger impact. So, first of all, let's fix the logging, okay, to bring some awareness, to understand what is happening. The logs before we fixed were just log everything, not open telemetry, not application insight, just look into the machinery, the deep machinery. And we have requests, we had traces, we had dependencies. Have you ever looked in Azure, in application insights, what hides behind the request? It's like 50 things are happening, and they were logging all those 50 things. Then, after we validate the thing that is coming from the payload that is coming from the portal, and I remind you, just 1 minute, that it looked something like that. So here is their portal. So they are sending an API post request to me with a payload. This is where the order is. Then after we validate that the order looks fine, we just tell them, you know what, you're good. You can go home. I don't need to do anything with you anymore. You sent me an order. It is valid. You have enough money. You have enough in our contract. Everything's good. Go home. You don't need to wait anymore. Then we started to untangle and simplify the processes. Like, why do all those logic apps need to speak with each other? What are they doing? For some of them, I need to... We're recording, right? Okay. Yeah. We simplified the process. After the recording is done, I can tell you a bit more. Then It ended with removing all the low-code solution, no logic apps whatsoever. I'm not against logic apps. I'm a little bit against logic apps, but I think that they're good for some purposes, like for fire and forget tasks, for sending emails, for doing tasks that nobody has to wait for them to be done. And then instead of taking data that is not changing from the database, just cache the thing. Just put it in cache and get it from there. Why do we have to speak to database to get customer information in every single request? The customer information never changes. How often does a client change the name? Not very often, I think. Okay, and now let's get nerdy. So, how do we implement validation and then fire and forget? Remember I had 1 million functions before? Yeah, I removed all of them as well, together with the logic apps, and I implemented a special kind of functions called, I could stack. What are those called with orchestration? Durable functions, thank you, durable functions. So, how do they work? We have 3 types of functions for those. First we have the trigger, then we have the orchestration, and then we have at least one activity function. So the trigger starts the whole thing. The orchestrator is the one that starts the activity, which does the real work. When the real work is done, the orchestration restarts, because it was sleeping before, restarts, gets done, gets to the next step, and so on and so forth. So, in this step, we have API management calling in the backend this HTTP start. And this is where we perform the validation. We take the payload, which is in JSON, we deserialize it. If it breaks, give them a 500 direct, already there. We don't need to check with the contracts and everything. The order is bad request, 500, we're done. Then okay, looks good. Okay, but how good? Like, did they order 1 million boxes of milk? That's a bit odd. So there, we have already in the memory, in cache, all the requirements for each and every client, and they are like, how many could it be? 500 clients? So 500 dictionary with 500 items, it's nothing. So check that the order is valid, and if it is, just tell them, you're good, 200, you can go home. After that, or actually before going home, the starter function not only validates, but it also gets the orchestration started. This means that if we're running a marathon, I got the pin, I saw the pin, it looks good, I made sure to give it to the next guy, and then I told him, no, now you're okay, now you can go home. So it is valid, and I have asked the next step to begin. So let's go a bit further. To gather, process, and create all the data. One moment. Okay, so the pattern I implemented there, and I think it's quite obvious, is chaining the functions. So what the orchestration does is that first it speaks to the server, to the SQL server, if needed. If we don't already have everything in cache, then just take it from the server or put it in the server. Then we have all this on-premises stuff, and on-premises stuff is slow, and we don't really need to wait because it's only backup. So the second activity function, after the first is done, the second activity function is going to send a message to Azure Service Bus. Azure Service Bus is a message broker supporting topics and queues, and the difference between queues and topics is that the topic can have multiple receivers, and the message is delivered to every receiver. Or, to be correct, it's being available to all receivers. So we have one function picking the message, sending it to the on-premises SQL database. This is for tax reasons, because they have to have a record of everything in their own on-premises database. It's not allowed to leave the country and stuff like that. Then we have the CRM data for their customer register. And then we have a filing thingy. I don't really understand what it is. We just created files in an FTP server, and then something happened with those. But those things, even if they break, since I have them in service bus, the worst thing that can happen is that they end up in the dead letter queue, meaning that they're in a place where a human being can take a look at them and handle them appropriately. Then, after the message is sent, and then this is asynchronous, so we don't wait for those. After the message is sent, then we go to the next function, which will create an invoice, and it will put it in a storage account. Now, it's not in this diagram, but from the storage account, we have a separate, but just simple Azure function with a blob trigger, which picks the invoice and makes sure that it gets sent to the client. Then all of those functions are connected to the same application insights instance, meaning that I can follow the orchestration everywhere in every single step. And I will show you how in a minute. I can put the order number and understand what happened, where did it get stuck, and how am I going to solve it from there. So let's see, yeah.
What kind of cache do you have there?
I'll get to that in a minute. Let's start with logging before the cache. So there is a Swedish word called lagom. Lagom means just enough, not too much, not too little, just a perfect amount of logging. So we don't cast dependencies, we don't cast traces, we don't cast requests. We cast log. We log what happens in those requests. So by using scopes in our functions, we make sure that every single log in this application insights instance will have some custom properties. Okay, and when looking for this custom property called order ID, and I put a GUID here, I'm sorry for the resolution, but I guess you understand. Putting the guide there, I can see exactly whatever happened, no matter in which function it happened. So I can follow, this is the starter, this is again the starter, now the orchestration, starting the orchestration, performing action, fetch data, preview data, export data, completed. So the whole process, step by step, is getting logged in one place. This means that nobody has to call me anymore. They do have access to application insights. They know how to use it. They don't need to have a developer looking for those. And then this gave me a lot of goodwill, actually. They started to like me or to hate me a little less, which is a success. So now it's time for me to come asking. And I told them, please, just, I know, they told you it's free. You know by now that it's anything but free. But just let me use some decent varieties of the resources I'm using. And I mean, it's not too bad. It's a B2. This is, I don't know, $50 a month. It's nothing. And then the service bus, if I don't use the premium tier, then I have to use the standard tier. And the standard tier can go for sleep, like for a couple of seconds. And it's okay to go for sleep if I have sent a message. But if I haven't, then I can't send the message. So I can't go further in my process. And their answer to those were, no, no, no. You told us it was free, you will make it free. No, I won't. But okay, you told me the cheapest tiers, let's do it with the cheapest tiers. Now, this leaves me with a few weak links. And again, let's take it from the left. So the API manager is going to call the starter function if the starter function is available, because it runs in serverless mode. And you know, serverless mode means that you throw a dice, maybe you get 5, maybe you get 6. So, of course, it's not happening very often, but we have orders all day long. So it did happen maybe once a day, every other day. It did happen that this wasn't available. So we have to find a way to solve this. Then we have the Azure function talking to the SQL Server all time. Again, we need to start caching things. And then we have the service bus being in the standard tier and going to sleep. And we have to tackle this as well. So, First things first, with the first part on the left, retry logic. Like, you don't allow me to use a more expensive tier. You don't allow me to use a more expensive tier in the API management, which has this out of the box. So I have to put it in the policy. This is like in the manifest of the API, that in the backend, while you are calling the backend, which is the Azure function, the starter function in my case, just retry. If it fails, and if it fails up to 5 times, then wait for 3 seconds, and then delta means the difference. First time you wait 3 seconds, then you wait 6 seconds, then 9, 12, 15. And this is your 5 times. If it fails for the 5th time, then odds are that something is wrong in the order. It's not the Azure function that's wrong. Maybe, and not in the order that the customer sent. Maybe they try to send a file. Maybe the order is too big for some reason. Maybe the JSON is broken. So it's an error in the machinery. So if this happens, then give them an 500 and make them call someone. Okay, then the same thing for the service bus. And now finally, some C#. They have out of the box this little thingy called call activity async for the durable functions, and you can put some options there, and those options, amongst others, have retry policies. Look how easy it is to create it. You don't even need to know what it does. Task options, static from the retry policy, just a new one, and again, same thing. Start with waiting for 5 seconds. Then wait for 8 seconds, then wait for a bit more. And we wait successively more in every try to give it time to come alive again. And then you will try this for maximum 20 times. This number is not really random. First we tried with 5 times, then we tried with 40 times, and we found out that like with 20 times we fixed 99% of the problems, and it was fair enough. And then to answer your question about caching, we used Redis, actually, with an asterisk. I'm coming to that. So the algorithm there is pretty simple. For whatever data that you want to extract, instead of looking in the database, first look in your cache memory. If it is there, then use it. So if it is there, then you don't get in the loop here. But if the JSON is null there, then you will get in the loop, and then we ask the database. And when we get the response from the database, the first thing we do is we put it in Redis. So here we have a get value, and here we have a set value. So if we don't find it when we do get, we will put it there when we do set for 30 days. This is what we deemed appropriate for data to keep like unchanged. So the customer name, the customer's address, they never change. I mean, come on, it never happens. So 30 days is fair enough. For other things, we had like a minute, like for JVT tokens. And then after that, again, the algorithm is pretty simple. So if we did have a value here, then we never get in here. After that, we just deserialize the JSON, put it in the customer, and continue with our lives. So, the results. Yeah.
About the customer configuration, is there a possibility that you change the time?
Yeah, of course. But in that case, we have internal processes, and the person who is updating the register is going to notify the IT people to purge the cache manually for this specific customer. Since it was Redis, they all had access to the Azure CLI to delete this entry from the dictionary.
How about the cost of Redis?
I'm going there. I didn't know in the beginning. I knew after the first invoice. Okay, so the results. Actually, it wasn't 40,000 requests. It was over a few hundred thousands per day. So we ended up with, it's actually almost 3 million process requests per month, which using the cheapest tiers, it's just fine. It's a good result, I think. We managed to broker 1 million messages per month, 150,000 cache hits. It means that 150,000 we didn't ask the database for something. That's quite good. And then it all ended up in 5,000 Swedish crowns, which is like 500 euros. Before that, it was between 3,000 and 4,000 euros. So they were pretty happy, although not zero, but still quite okay. We never lost an order, we never missed an invoice, and the negativity disappeared completely. We even have a zero-ish manual intervention. As I said before, sometimes users are users, they will manage to do a mistake. Sometimes they will copy things, and copy and paste, the comma will become a dot, and you have issues like that. So, of course, it doesn't have to be totally perfect, just perfect enough. So, I'm close to the end. The technical lessons learned. The logic app connectors have limitations, and those limitations, in my opinion, make them unusable in production if you have heavy loads of data. The durable functions need a bit of configuration because the default actions have, for example, parts where there is a limited number of activity functions running in parallel. I didn't have any issues for them running in parallel, since every customer, it was a multi-tenant solution, every customer had their own data, totally fine. Then Redis is a free lifesaver, free because it's open source, but managed Redis is a cheap lifesaver compared to the previous one. And even cheaper, which is what we ended up with, is deploying Redis in a containered Azure function. This put it to almost zero, and this is how we solved it, to keep Redis very, very cheap. Low code, it means high maintenance, and this costs us a client in the end of the day. And to exhaust the app service plans is also a good thing to know, because the app service plan is the hardware itself. It's what we pay for, and since we pay for it, we have to use it as much as possible. Now, the non-technical lessons learned is that asking me to create a stable solution isn't asking me to create an unbreakable solution. It's fine if something goes wrong once in a while, as long as we have good logs, as long as we can make sure that we can recover from that fail, from that mistake. Then, of course, we can test various things, but in the end of the day, we have to deliver value. This is what they pay us for. And then when we do deliver value, we see that it's not about money they're crying, it's the return of investment. This is what the clients need. They're happy to pay, but they want to get back the value for their money. Then being honest and owning your mistakes lets us build a relationship of trust. Then they're happier to let me test other things later. And that awareness creates confidence, meaning that if they do have access in the logs themselves, they can find themselves the mistake, and they don't have to take my word for it. This also gave me a lot of confidence in that project. So that was pretty much all of it. Are there any questions? None? Thank you.